Landing a rocket without letting it explode or end up in the ocean is challenging. But Elon Musk has devised a brilliant plan to prevent that from happening. SpaceX may be undertaking a dangerous maneuver, but the rewards would be enormous if it succeeded. Will the launch tower rescue all 33 engines, and how will Elon use it? Today's video is about what Elon Musk's genius design will save 33 engines. Before we start the video, please like, subscribe, and press the bell icon. Mecha Starship is SpaceX's most ambitious project yet and is already making history. The 120-meter-tall spacecraft, which is still in the testing phase, is already the world's tallest rocket and can launch 100 tons, or 100 people, into space at once. The spacecraft that will herald humanity's return to the moon and open the path for more was explicitly chosen by NASA. By doing this, Falcon conserves fuel, which may otherwise increase its dry mass and reduce payload. Contrary to what you might think, neither it nor the idea has been publicly discussed. The idea generated much interest when people published films explaining how it might function. He posted a video in 2021 detailing just how that will operate. The 400 feet tall launch tower, known as Mechazilla after the Mechagodzilla character from the Godzilla movie series, is intended to serve as both a launch and installation. It is equipped with 3 arms crucial to the Starship's functionality. The first arm connects the upper stage to other utilities and holds heavy objects in position while they are being installed. Starship's upper and lower stages are lifted and stacked by a more unusual set of arms known as chopsticks. Depending on the situation, the booster can move toward or away from the launch tower using a pair of parallel screw rods on each arm. SpaceX will use these arms to catch the rocket as it returns to the planet. But exactly how will this catch take place? The Heavy will burn, do a boost back, and then fall to the ground. To control the pressure and guide the craft toward a vertical landing, it will be equipped with not retractable steel grid fans on the side. Its return must be highly accurate because the cumbersome object must fall on 2 hard points on the tower. By catching the upper and lower stages of Starship, SpaceX hopes to reduce mass, avoid the expense of adding legs to the craft, and have it ready to fly in an hour. The launch tower won't exactly catch the booster because it's more like a fixed landing platform capable of last-second positioning adjustments. The Falcon 9 boosters typically touch down in landing zones, fall into the ocean, or land on ships at sea. However, before they can be used, they must be carried back to facilities. Elon hopes to solve this issue and increase landing precision with Starship's groundbreaking rocket recovery mechanism. Elon Musk and his group started seriously testing Mechazilla on January 4th. To the delight of onlookers, the tower's building-sized arms were hoisted, opened, and swung for the first time. A few days later, SpaceX conducted more tandem swing tests with the twin arms and conducted some preliminary testing with the third fueling arm by swinging it in the direction of the Starship. The business conducted a third series of tests demonstrating fundamental actuation and coordination during installation. The primary function of the arms is to securely and precisely lift and stack Starships and extremely massive boosters, which will also be utilized to capture rockets. Fast forward to August, and the launch tower was able to finish the test without any significant issues successfully. At Starbase in Boca Chica, Elon shared a photo of the Mechazilla hoisting a fully stacked Starship prototype onto the launch pad. Mechazilla has been crucial in helping the firm prepare for the maiden orbital launch of Starship by providing the means to quickly stack the rockets for static fire tests and separate the sections so that adjustments can be made immediately. Will it function? SpaceX is a firm known for breaking and fixing things, so they'll keep trying to make it work until they're convinced that the launch power won't be the best option for recovering the rocket. The first orbital launch of a Starship is already scheduled to take place from the tower, although doing so entails several dangers. Using the launch tower will only heighten the risks associated with this initial launch for Starship. The launch pad and launch tower could be damaged if the landing attempt is not precise to the last decimal. Therefore, if SpaceX has yet to perfect every design element, testing of future prototypes may be delayed by months. A spin test with us. Although the booster's explosion didn't seriously harm the pad while still on the ground, it warns about what could occur if SpaceX handled this mistakenly. However, they are presumably already aware of this. Musk and his team know that the Super Heavy must be in good shape for launch, perform flawlessly throughout it. Additionally, there shouldn't be any hedging on the launch's boost-back components. NASA declined SpaceX's request to use the launch pad at the Space Kennedy Center for its launch because it is aware of the potential danger involved in the launch. NASA turned down the company's request despite having projects in the works to ensure Starship's success. Elon Musk could not guarantee that vital infrastructure would be protected during the launch. Instead, SpaceX's launch pad in Boca will be used for the orbital voyage. The margin of error for this project is tiny, and even the slightest inaccuracy might cause the rocket and launch tower to crash into the Earth and an explosion that could destroy the surrounding infrastructure. If SpaceX, for some reason, elected to place the Falcon booster on 2 higher ledges, the task's difficulty would remain the same. They are around the width of a car. The significance of proper rotation control in challenging situations cannot be overstated. Despite intending to conserve as many resources as possible, if SpaceX chooses to employ Mechazilla, the booster's return will cost more Delta V or fuel than the Falcon's suicide fire. The Super Heavy will probably need to consume 5 to 10 tons of propellant because, to its long drop, extra fuel will need to be added when it reaches the ground because of its delayed descent. Understanding how this technique will speed up rocket reuse is also challenging. The rocket's successful landing on the launch tower will eliminate the requirement to reattach the arm to the booster or upper stage of the departing ship. This might be inaccurate by a few minutes or an hour at most, but it won't significantly alter the results. If SpaceX uses the same landing technique as with the Falcon booster, which it has already done with great success, it won't have to worry as much about the rocket's ability to be reused. More significantly, this approach has never been tested. In the footage that Musk made public, the booster is seen softly touching the chopstick's pointed ends. In reality, though, this would not be the case. The rocket's arms must be powerful enough to withstand the shock of the landing and bring the rocket to a complete stop. But it's a great concept to take the booster's leg out of the equation. They would still require a mass budget of 10 tons for each leg, totaling 20 tons, if they were to enhance the Falcon's legs by adding more short fixed legs. Due to the intrinsic physics of rocketry, the payload of a super heavy rocket with a 200-ton dry mass will be reduced by up to 5 or 3 tons by adding 20 tons. However, it must be tested further before being utilized to collect rockets. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content.